Hello there, I'm Dominic St-Pierre and you're listening to Go Podcast. Today I'm joined by Morgan Hallgren and we talk about event sourcing in Go. Before we dive into the episode, I'd like to remind everyone that there is a channel on the Slack Gophers that is called Go Podcast. So in one word, Go Podcast. So if you want to join that channel, that will be nice. So we are just a small number there, and not sure what to do to bring people in there. So hopefully I'd like to build a little bit of a community there. Maybe to have some questions for the guests that are coming up and things like that. So if you want to join, that would be nice. So on that, this is the interview with Morgan. Hello, Gophers! This is a very exciting day for me today because I'm receiving a listener of the show, actually. So someone that is listening to Go Podcast. Thank you, Morgan, for joining me for this episode.
Yeah, thank you for having this show.
Cool. So, as you might be familiar already, I like to ask my guests to introduce themselves. So it's just for listeners to know a little bit about them and things like that. So anything that you want to share about yourself. So what I typically like to hear, especially, is where have you started in terms of your software engineering path, and as well, how have you discovered Go at some point in your careers, and what are you doing at the moment, and things like that. So anything that you want to share, we will go from there.
Yeah, sure. So I've been a heavy user of Ruby in the past. So I have done a lot of web-based things in Ruby, tried Ruby on Rails, and that area. And then I started a new job, and then I was forced into Go for like 7 years ago. And in the beginning, it was really strange when you come from Ruby, because in Ruby you can do a lot of magic, and in Go you are really pretty forced into the Go idioms. But now, after 7 years, I really enjoy Go.
Yeah, I can imagine that it's a pretty huge clash between the two. So, is your current Go gig involve any kind of web development, like you were doing in Ruby?
No, it's mostly backend stuff. We have an API, but it's GraphQL.
Okay.
But otherwise, it's no web at all.
Oh yeah, so that's a big change for you. I must imagine. So starting from Ruby. So were you? I'm curious a little bit about that because going from an MVC pattern like Ruby on Rails and going to start writing Go API, which is a little bit. Let's say verbose at first, I can imagine, for someone coming from Ruby. Was that one part that you were finding difficult at first? Just to, I won't say overwhelm yourself with writing a lot of codes, but the amount of code that you need to write to do the same thing in Go is kind of crazy.
So I wasn't really into the Ruby on Rails framework. I liked smaller web servers like Sinatra.
Oh, nice.
So I was pretty already doing more simpler stuff than Ruby on Rails.
Yeah.
So yeah.
Yeah. Okay. So that's good. So and correct me if I'm wrong. So Sinatra does not have an ORM and things like that, right?
No, not out of the box. You have to do that yourself. So it's just a web server handling the requests. If I remember it correct.
All right. So that is similar to what you can have at first with Go. I can imagine then if you just have your web server and you're responsible, so you don't really have any kind of middleware already baked in and things like that. So you have to write all the plumbing, if I can say that.
correct. Yeah.
Oh, that's good. That's good. And so, how long have you been writing Ruby before Go?
I think it was 6 years or so. Yeah.
Okay, that's nice.
Yeah.
And so far, would you say that if you were to have to write a web application yourself, would you go with Go, or you would still consider something like Ruby or maybe Python?
Absolutely Go.
All right.
I'm 100% Go nowadays.
Great.
Actually, it's hard to remember Ruby after so many years.
Really? Yeah.
Yeah.
Oh, that's interesting. Yeah, for me, one thing that I was finding very, very strange with Ruby was the question mark at the end of certain function or method at some point. I was like, really? I mean, this is interesting to me.
Yeah, but also you can change like the meaning of functions.
Oh yeah,
object. Yeah, it's crazy.
Yeah, it's not as dangerous as JavaScript, I would say, but yes, I've heard a lot of stories with the meta programming and whatnot. It's crazy. We don't have that in Go.
No, thank God.
And exactly. I just hope that it's never there. So you wanted to talk about event sourcing today.
Yeah. So I've been doing event sourcing. I started in Ruby, actually, and me and my former colleagues were doing we developed an application based on event sourcing. Then I entered my current job, and so I was interested in Go, and when you are interested in Go and event sourcing, you want to do event sourcing in Go. So I've been building a set of modules for doing event sourcing.
Nice. So just for listeners that would not have any previous experience with event sourcing, so how would you describe that, or how would you compare that to a typical CRUD application, for example?
Exactly. Yeah. So in CRUD, you read your entity from, let's say, an SQL database, and then you mutate it, and then you write it back. So you working with current state. And if you compare that with event sourcing, everything you store is events. So you read events and you save events. So when you do a mutation on your entity, you don't change the current state of that entity. You generate new events that you are storing later on.
I'm probably hearing a lot of listeners at the moment that might say, "What? This is kind of crazy. Would that not, triple, quadruple, maybe 10x the amount of data that the database is going to receive?"
True. So yeah, you shouldn't run this if you have limited amount of space. So if you're running on-prem on an embedded device, you should probably not use sourcing. No.
Yeah, probably not. So would you say okay, so there is we can agree on that there is probably certain kind of system or domain that might not work at all with the event sourcing pattern.
No, you should, if you have, you should use event sourcing where you want to know the history of things and how you end up in this state. So you shouldn't use event sourcing on every part of your application. So focus it on where it makes a bang for the buck, so to say.
Yeah. And what is the benefits? Because if you're saying that it's to know the history, what is the difference between having, say, a table that would log some history for certain things, but having a field status? Let's have the. I always hear the an order an order system. For example, a customer wants to purchase something, and now the order is placed. The order has a state, or at least a status. Is it waiting for someone to process? Is it waiting for the payments and things like that? Mm-hmm. So what is the benefits of having events being accumulated and not having a status field in a database?
So I think one really nice benefit is that when you talk to your business people, they often talk, their language is events. So they don't talk about like changing a state on an entity. They talk about, placing an order, adding items. And those events are later than changing the status of the order itself.
That's interesting. Yeah, that's interesting. I like that a lot. So it helps you. It helps you talks with probably management or other business people that understand the business case. Let me ask you something then. Is an event supposed to change only one aspect of the entity, or it can means that it also modify one or two, maybe more than one field in a typical entity?
So the cool thing with event sourcing is the only state you have is event, and the entity state is calculated based on the event. So the cool thing is that you could change the structure of the state of the event however you want, independent of the events. So you can build your state. So the order itself it's built upon the events. So you iterate the event and you build the state of the order in this case.
How do you know? Yeah, that makes sense. So how do you know where to use event in your system then? Because at the beginning you were saying, you should not be using event sourcing for all the domain entity of your business problem that you're trying to solve. So how do you spot a place in your system that you say to yourself, well, here we should use events instead of having to mutate our things?
Yeah. So if the history of how you ended up in the current state is important, I think it could be a good place to have event sourcing.
Probably even being able to replay history might be something that could be a factor to decide if this piece is good or not. Because correct me if I'm wrong, but once you decide to go with event source, you have a super control to go back in time and change history as well.
Yeah, you can go in time, so a specific date, and see how was the system looking at this point. So you have full control of how you ended up in this state.
But is it like Git, where it's kind of there's this phrase in Git that says, don't rewrite history. What happened if for some reason there is something wrong with a system, and now you need to decide, well, should we go back in time and delete some events, or we should continue adding new to change the state?
If you want to be pure, you should add events. So if you want to be using event sourcing as it should be used, you should add events that change the history. So append new events. But you could, if you want, go in and delete events, but then you have to know what you're doing.
Yeah, I'm assuming it comes with great responsibility.
Yeah, with great power. Yeah.
So, okay, and And how do you handle? So I would imagine that you need to store those events somewhere. I mean, is there some event source database that you have used that is better than other? And what are the factors that you inspect to decide what to use for your system?
Yeah. So you can use I'm really liking like simple things. So my first go-to is SQLite. So SQL database storing all events in one table. But there are like event sourced databases like Event Store DB if you want like store a lot of events. But it depends on your application and your needs.
So you are storing all the events in one table. So when you say all the events, is it related to one entity? So let's continue with our example of the order system, for example.
No, it's all entities.
Oh wow!
So if I have like a one SQL database, I have all entities in one table, and they are ordered. So each entity, like say order 1, all its entities are in that table together with other orders, so to say.
Okay. So and what it is like to build a system like that? Because let me throw some scenario at you. So let's continue again with our ordering system. Mm-hmm. So I would imagine that it's best fit for microservices architecture, where a small piece of the system is handling a small business operation. Maybe we can say that. Mm-hmm. And that thing probably has its own database. So I would expect that this is where the SQLite make a lot of sense. Mm. But let's say that you have an API that expose the one particular order. So other systems need to pull this order, say, you know what, the order 514, what is its status at this moment. So you need to pull all the events from the SQLite database and recalculate every time that someone is asking a question.
Yeah, you could do that. So if you have two systems that are separated, the other system could subscribe or pull the events from the first service and build its state based on the events. So maybe it's not interested in the order as it looks in system service A. So it can build its own representation within its own context. But then you have to, either you get all the events, or you can have some kind of query that pulls the events you are interested in for the service.
Is it a common practice to exchange events from system to system? Not as they are, occurring, but at some point, one system might ask, give me all your events on X.
Yeah, that either you have like a pub sub system that's pushing events, or the service could by itself fetch events from the other service. Yeah.
Nice. Yeah. So I would expect that you are mostly using microservices in your architecture usually.
I like the domain-driven design idea of bounded context. So okay. Each context could have its own way of storing things, but then you could build it like a monolith based on this context. So it doesn't have to be microservices.
So at the end, you are still like deploying a single binary?
Yeah, that could be the case. Yeah.
Interesting. What about versioning and schema changes about an event? Because I I would assume that if you're storing that into an RDBMS, maybe at some point might be rare, but the data might need to change for a certain event, and now there's a lot of complications since it's not a document database, for example, where everything is like JSON based and things like that. So how do you handle that?
Yeah, so each event within one entity has an internal version. So version 1 when the order, for say, was created. Version 2 when an item was added or something like that. So each entity has an internal version. And then the global version, so all entities have a global version as well. So they are ordered between each other. And the data within each event is based on your application. So in my case, I have like a blob for the application data. So each event has like a version, global version, identifier, which entity it belongs to, so an order, and also a reason, and that's like order created, item added. So if you have defined an event like order created, that should never change the data in that event. So if you want to change that data, you should name the reason order created version 2 or something.
Okay, so are you saying that you have like a bytes columns there that you can store more information, and this is what would change, but the rest of the 3 or 4 fields that you just described kind of never have to change?
Yeah, so the specific event that you store in the database is immutable. But yeah, the field holding the application defined event is a byte slice, or yeah, some kind of blob.
And that is what, JSON at the end of the day, or
it could be JSON, yes. Yeah.
Okay.
Yeah.
So I would imagine that those database tends to grow fast. But is there any kind of, I don't know, read performance at some point for when you need to scale that a little bit? And especially since you need to like recompute all, you need to recompute every time that someone needs. So what it looks like because when you just ask for order number 1, it's not that bad. But let's say that someone wants to know all about the orders of a certain customers. So now they might pull a list of, I don't know, 200, 300 orders, and now you need to recalculate all of that.
So we could separate when you're gonna fetch one order. So if that order, say, it's been alive for a long time and it has like thousands of events, then you have to fetch all those 1,000 events and rebuild the order. And there is a concept called snapshotting. So on event version, say 1,000, you say, I want to take a snapshot of the current state of this order. So then you store the current state of the order with the version 1,000. So when you read that order next time, you first read the snapshot, and then you read the events that has been saved after event 1,000. So then but that's only for optimization if you have entities that are really large. And of course, it depends how you model your entities. But if you want to read like many events, out of many orders, I would recommend a read model. And a read model is generated based on the events from the orders. So you build a separate representation that is more focused on the way you want to read the data.
Okay, and that is that what your GitHub open source project is doing at the end of the day?
Yeah, I have like separated in different parts. So I have the aggregate, that is the domain driven design name of an entity. So there is the focus on how you're going to model your entity and your events. And then there is another part of the project that focusing on the projection, the read model, and how you can build separate states based on the events.
Interesting.
Yeah, so you have more. So in a traditional system, you have like one model that is focusing on both read and write. But in event sourcing, when you model, you are focusing on writes, and when you read, when you want to query data, you are focusing on building separate representation based on events. If that makes sense.
Would you say that this type of system is better for when you are having a lots of concurrent writes, and now you don't really need to, to bother with any kind of deadlock or who's having the proper entity state at this time of the writing? Is that why, a little bit why this we would choose that?
I think you have a concurrency lock. So if you read order 1 and you generate new events on that and try to store it, if someone else has stored events after you read order 1, you will get an error that there is an optimistic lock. So it's not about concurrency. It's more, modeling state in events instead of modeling it in only mutable state, if that makes sense.
And how the system knows. So that means that when you are fetching one entity, you still need to keep a connection with the database and knows, for a certain amount of time.
No. So when you read, you get all the events, and each event is versioned. So the internal version of your entity, order 1. So let's say you have 5 events on order 1, then the current version of your entity is 5. So when you append a new event, it will get the version 6. And when you store event version 6, the database will check, is there an event with version higher than 6 or 6 or higher? Then it will say no.
Okay. Yeah, got it. So because let's say that for some reason someone would have also write in between your save.
Exactly.
Yeah. Okay.
Yeah. So only the first will win. So then you have to read the events again.
Oh, yeah. Okay.
Try to do it again. Yeah.
Got it.
Yeah.
Interesting. Okay. Yeah, makes sense. So would you say that there is some pitfall in event sourcing that well first of all this streaming of event, or at least the aggregation, seems to be, I don't know, a little bit counterintuitive when you are not used to do that?
Yeah, it's really mind-bending.
Yeah.
Because you have to think in totally different ways.
And have you seen problem with that in production? So is there challenges that you don't really have in a I would say a typical RDBMS system?
The challenge is that you often name your events like order created, order updated. So it's really no business value in the events.
What would be a good name then?
It should really, depending on the language of the business. So if they are like saying something in a specific way, you should try to model that in your application. So for the order, let's see, discount added maybe. So it's really what's happening actually. So all events should be named in like past tense. So it's a fact. Something has happened.
Right.
Yeah.
And is it complicated if let's say this order has multiple type of events, reconstructing that? So would that means that you would need to iterate over all the events that says that might be for the status of the event, and all the event for, I don't know, price changes, for example, which might be a totally different things, or
you have so in your application on the entity you have defined every event that is possible for this entity, but the event could have the same data but it's named differently, so it means something else. So
right.
Price, race, so you can really be more specific in your design.
Yeah, I can imagine that it might be rough. So it's already extremely difficult to to name functions and name things, and now you need to really think about that. Your event, because they will probably stick. It might be extremely rough or difficult to change an event name after.
You have to create a new one, and then you should. Now we're using the new one, but you have to take care of the old one as well.
Yeah, but that's my point. I mean, the amount of codes that needs to stay there for. But maybe with the snapshot things you could.
Yeah, snapshot is only for optimization, so it's nothing about the events in itself.
Yeah.
Yeah, but then you could. I'm gonna say I kill this order. Now it's order 100 instead, and here is the event for that. So it's a new entity.
Oh yeah, okay, yeah, I see what.
So maybe you could I'm closing the book for this.
Right.
I create a new one.
So I guess there could be an initial event that says this is a starting point of your state, and from there.
Yeah.
Oh yeah. Okay. Yeah. I'm starting to getting it a little bit.
It's a hard topic because it's really, it's a different mindset.
Yeah. I always saw this as being, really good when you need to perform a lot of operation when something happens. So for me, that was more the reason to choose event sourcing was more like, something happened in the system, and now there is, I don't know, 3, 4, 5, 6 small things that needs to happen at the same time, but they all can be, parallel, if you will, or they could be anywhere in the cluster or whatnot. And
maybe that's more event driven.
Yeah, probably, yeah.
So I see event sourcing like a way to protect the state, and then the event is a fact that happens.
Oh yeah, okay, yeah. I was probably confusing both things. Yeah. That makes sense. What about testing about your system? Is it that different than testing normally? Because now I guess you don't even need a database. You could just fakely just generate some event from your test and see how the system is handling that.
So I build it like I'm really focusing on the modeling. So I really like it to be as simple as possible. So when you design your entity and your events, you don't have to have a database. So you're modeling it's in pure Go structs. So when you do your business logic, you could write your unit test and expect events to be created on your entity. So you have your entity, you call a method, and you expect events to have occurred on the entity. If that makes sense.
Yeah.
And then I have a separate method on the module that stores the events on the entity to the store. And then that's a separate thing. if that makes sense.
Yeah. Do you have a lot of validation then? I mean, is this event even? I don't know. Is there any security? Attacks that can be occurring for that? Let's say that you have an API for some reason that would accept some events from the exterior, or is there anything in terms of security that needs to be taught a little bit more?
No, I don't think so.
No, because it's fairly internal, right?
Yeah, sure. So the API of the entity should protect you, protect the entity from generating event when the business rule isn't applied.
Yeah.
That makes sense.
Oh yeah.
So it's the same thing as if you are having a traditional model, but the only difference is that an event is generated, or instead of the state has mutated.
Yeah. Yeah. So would you say that at the end of the day, when you are looking at your code, it's a little bit tougher for someone that joins the teams that use event sourcing like that, if they are not really familiar with that? Have you seen that it takes I don't know, a couple of days, maybe 1 week before they are comfortable with the pattern?
I think the biggest hurdle is to understand the difference in how to think when you are using events instead of mutable state. But my hope is that it will tie closer to the business problem you are trying to solve. So it should be easier in that sense.
Yeah, that's the part I like about event sourcing. It's that might be it seems to be a good way to model the business operations and things like that. Yeah. So I mean, it's certainly interesting for that, but I don't know. It still feels a little bit. It's just because I haven't seen much code that would use that way of doing things. I'm not even sure.
But you should try it in a small portions. So
yeah,
like one entity. Try out how it feels there, and don't go big.
Oh no! Yeah, because that's a danger, I guess. It's that all of a sudden everything is event sourced.
Yeah, the problem. I've been there.
Yeah,
everything was event sourced, but it's really hard to do simple things because you always have to generate read models to be able to query things, and you should do it. Yeah, when it matters, there it should be used.
Yeah. Yeah, the aggregation to me, and especially when, like I was saying, when you're pulling lists of things and now you have hundreds of entities that need to recalculate all their events themselves, there has to be some performance hit there.
Yeah, but then you should have read models, and the read models should be asynchronous from when you generate the events. So you could read the events, build some kind of read model. It could be a graph, it could be SQL, it could be whatever. And then you could query that for performance. And you can really form that to fit the query you want to create.
Okay, but how do you know when to update this graph then? Who's responsible for?
So you have your event stream. That's all events in your system.
Mm-hmm.
And this read model is reading that one after another and apply that to your read model, to this graphs, for example, updating it depending on the events that it's reading.
So it's constantly doing that?
Yeah.
Oh.
In its own pace. Because the write side is just writing events, and the read side could, like for batches or wherever you want, updates in its own pace.
Wait. Oh, wow. So this is even stranger in my head now. So we are kind of back to what an RDBMS is in a sense then. That is crazy a little bit. So
the event sourcing is like a sequence of events, one after each other, in an ordered list.
Yeah.
So you can generate for like a report in a graph, reading event 1 to end. But you could also want to generate a SQL database with some kind of schema, and then you read event 1 to the end. One after each other, and just generate that structure based on the event types.
Right.
So you know exactly how the events are structured and the data in them. So you can just take that data and put in your read model however you want and fit.
That is so interesting. I mean, okay, I wasn't seeing that from the beginning of our talk, that there were a reading part that was doing that.
Yeah.
Okay.
So that's the read side, and then you have the write side when you model and create your business logic. But then when you have the events, you can say, okay, what can I do from this? Oh, I can generate a report in this format. Because you have the facts. This is on the table. This is the things I can work with.
Right.
And the cool thing is you can regenerate this read model how many times you want, because you have all the states and all the history is there.
But is the read process restarting from scratch every time, or it says, you know what, in my current state, this entity is at version X, and now it's at version X.2. Is it grabbing all the 2 new events, or it's starting
so the read model can by itself know which version it read last time. So if it's on the global version 1 million, okay, next time I take 1,000,001.
Okay, yeah.
And then I just iterate there. So it's the read model's job to know where it's are in the event log.
And do you have this part in your library?
I have how you can iterate this sequence of events, and there is a callback that you will get the events, and then you can do whatever you want with it. So I haven't supplied how to write the event to any read model. That's your job.
Right. And from the point of view of your code architecture, let's talk a little bit more concretely, because I really want to understand. So let's say that you are creating a function in your code that is exported. Let's say you are creating a package. I would assume that the consumer of that package, let's say we want to place an order, they don't really have to know that at the end of the day they are going to create an event.
No.
Right.
So from the outside, it's just a method.
Mm-hmm.
And the events is handled behind the scene.
Okay, yeah. Okay, that makes sense.
So how I build it, so you have your entity, and you embed. I have something called aggregate root. So it's also from domain-driven design. And when you embed that into your application entity, you will get the behavior of event sourcing. So I have like exported functions on the module aggregates, so you can add events to this entity. It's hard to describe it in words. It's easier if I could show it somehow. But yeah, I could say there is behaviors on this embedded entity that enables event sourcing and adding events to this entity.
And is it this aggregation root that knows how to talk to the the underlying, event source at the end of the day?
No, so it's only know how to create event and store it on itself.
Okay, yeah.
And then you are passing that entity to an external function that will grab the events that are in flight and store it to the underlying database.
Okay, yeah.
And I have an interface, so I have like SQL, like database SQL interface, and then I have Vault and event store DB. So you can generate your own underlying database and store your events.
Okay. Yeah, that makes sense. Nice.
So I'm really focusing on how to model without tying it to a database. I want to be as free as possible when I model.
Right.
To be able to iterate quick and don't have to update database schemes and whatnot.
And what about the global version of the entity that you were mentioning? So I would guess that this is somewhere in your table as well, in your SQL Lake. Okay.
So when you store the events, the database will. So in the SQL case, it will use auto increment and store that, and it will return that to the event. So when you read it the next time, it will have this global event.
Nice.
Attached. So the projection is doing the same thing. So when you read events, each event will have a global version, so it can store it and know where to start when it's going to apply the next patch.
Okay. Yeah. Have you used the replayability in production? At least one for this, because I assume that this is one of the other benefits is that let's say that there is something really bad that occurs on the system, but all the events were properly, I would say, logged or at least saved in the database, but the the thing that takes the event and should do X failed, it's very, very easy to just replay all of those things.
So are we talking about read models?
Well, more like writing events. So I would guess that. Well, again, I might be confusing with event driven now again. Yeah. Okay, so are you saying, well, so the replayability doesn't have any kind of effect in event sourcing? Am I mistaken?
So when you replay the order.
Oh yeah, okay, that's the only thing.
So the cool thing there is the state you are setting in the order. I always use that for protecting the entity.
Yeah.
So it's say that the order has a maximum price that are valid, I say. Then I can, if I have like item added and there are a price on that, I can like add that to an property on the entity, say current order value. And if a new method is trying to add a new item and that is over this limit, then the method would return an error and not producing any more events.
Yeah, I got it.
So the events is always representing like fact has happened.
Right. Yeah. Wow, this is very interesting. Would you go back to now that you are used to do that? You were mentioning that it's been 7 years that you are at the company where you are at the moment, and I would guess that you are using event sourcing. So is it part of you like fully now?
Actually, I've not used this at the company I'm at.
Oh, okay.
So I was actually helping a day trader.
Okay.
So when I was helping him, this project arise from that work.
Oh. Yeah, I can see for that domain that it's pretty important to have the history.
The cool thing there is so when you do trading, there are actually small events coming all the time with the current values in that trade or
Mhm.
if you say if you want to do trade on Canadian dollars compared to Swedish krona,
Mhm.
there comes like, I think it's called candles with the current value of the, let's say, a Canadian dollar compared to a Swedish krona. So I was using those values and pushing them into the business model. Bam, 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 bam.
Nice.
And then I have drawn lines in the graph. If this candle crossed a line, that generated an event.
Mm.
And that was a real domain event. So the small candles that came in was just triggers. So it wasn't real events. But when it crossed the line, it generated a domain event. And that domain event then could trigger other things like placing an order, drawing new lines that's going to be crossed later on, and so on.
Nice.
And the cool thing is then I have like the history of everything that has happened. So we could like follow the trades, exactly how they turned out. If that makes sense.
Yeah. Oh yeah. Yeah, that is great. I wonder how, it's possible to have this history, but I wonder, is it really used in every day to day operation and things like that, because it's there, but
Yeah, but you can generate reports on it and stuff like that.
what do you mean? Like ask a question like
the business wants. I want to report how many orders are in this state for how long.
oh
Okay. I have every date and every events with times, so I could generate something based on these facts. So you can now, you can start asking questions like that, and you have all the facts.
right.
So you can ask, how can I compose this to get that information out?
So it's a little bit more than history. It's really like, I would say, almost analytical data that you're getting from your system.
Yeah, and you get it for, I won't say free, but if you have thought about it, you have it.
Yeah.
So you don't have to, okay, I need a history of that, and now I have to store that in a separate history table.
Yeah.
But now we have all the facts because your system's state is built on it.
Why use multiple tables when you can use only?
Yeah, exactly. Yeah, and it's used. And it's not something you think about later.
Right.
So that's really cool.
SQLite is pretty impressive, I must admit.
Yeah, I use it all the time.
Yeah.
It's my go-to database.
A very, very nice project as well.
Yeah.
Cool. All right. So I mean, well, yeah. I think I have a way better grasp on event sourcing today than what I had before we started the episode.
I'm glad.
So is there anything any closing thoughts that you want to mention here? Any resources and anything?
Yeah, with great powers, as we said in the beginning, don't use it small. Start small.
Yeah.
Try it on one thing, and you can always go back if you want, because you have the current state of your entity, so you could store that in some other store if you want.
Yeah, so I can imagine that if you are changing your mind at some point, it's just a matter of recalculating everything that you have, and this is the source of truth. This is the truth now.
Yeah, and then store that and start doing the traditional way again.
Right. Yeah, that's pretty interesting. To be frank, I will need to read a little bit more on that to see if I'm usually doing small software as a service myself. So yeah, but I really like the historical aspect of questioning your data, or at least asking question. What happened from that date to that date and things like that. Not only that, but it's pretty interesting.
Yeah, and I really liked the cool thing is that the current state is always calculated.
Right.
So you can change that however you want because it's dynamic. In a traditional model, that's really static. It's really hard to change. But in this model, it's really easy because it's always calculated based on the events.
Right.
So the state has changed from a fixed entity state to events that is used to calculate this entity state.
Yeah, totally. This certainly has a great value for some use case. Don't get me wrong. I like you said, I won't do that everywhere. But yeah, I can see in terms of protecting data as well. This is a good way probably. Because now you cannot just, oh, I'm sorry, yeah, we did a bad update or we did a bad query, and now all the tables field X has been rewritten to something else,
and you don't know why, and what was the previous value?
Yeah, exactly. Yeah, pretty cool. All right. So, all right. Thank you, Morgan, for joining me today. So it was rather, very, very nice. And if there's other listeners that are listening that wants to come talk to or create, do an episode, that would be great. So thank you for that.
Thank you for having me.
All right. That's it for this week. I would really appreciate if you can talk or share about this podcast. It's always helpful. Also, another way to support this show is by purchasing my course. There's always a link in the show notes. So on that, see you next week.